is a collaboration with programming knowledge. Welcome to another playlist where we talk about how we can work and understand Springboot and JUnit. In this playlist, we'll talk about how we can use JUnit and write unit tests for our Springboot REST API application. We will do this by learning how JUnit works, what unit tests are, why do we actually need to write unit tests, and what does testing even mean. So we will start with the basics of what testing is in this video and slowly move ahead with basic unit tests, and then we will actually build our REST API and then write unit tests for our REST API. In this playlist, you can expect learning about TDD, which is test driven development, where we understand what that paradigm is, why that is pretty famous in the current software engineering scenario, and what do we actually mean when we say TDD or test driven development. So let's before all of that, let's just understand what testing is and what do we actually mean by testing a software system. So testing the system is an important phase in a software development lifecycle, the SDLC. Testing promotes code reliability, robustness, and ensures high quality software delivered to clients if implemented correctly. So testing has been given more importance since TDD has become a prominent process in developing software. Now, test-driven development entails converting requirements into test cases and using these test cases to gatekeep code quality. Now, code will be considered unacceptable if it fails any of the test cases declared in a system. And the more test cases we cover, the better the product becomes. The code base is lengthened considerably, but it reinforces the fact that the system meets the given requirements. Now, REST APIs are rigorously tested during integration testing. However, a good developer should test REST endpoints even before integration in the unit tests. Now, we have these two terms called as REST integration testing, unit testing. So let's understand what all of them mean. So before that, let's talk about the purpose of software tests. So a software test is a piece of software which executes another piece of software, asserting that it is behaving in a way that we want to. With software tests, we ensure that certain parts of our software work as expected. These tests are typically executed via the build system and therefore help developers avoid breaking existing code during development activities. Running tests automatically helps to identify software regressions introduced by changes in the source code. Having a high test coverage of your code, basically testing all possible edge cases in your code, allows you to continue developing features without having to perform lots of manual tests. Now, you should write software tests for the critical and complex parts of your application. If you introduce new features, a solid test suite also protects you against regression in existing code. Now, some developers believe that every statement in your code should be tested, but in general, it is safe to ignore trivial code. So, if you have a simple if-else statement or a for loop statement which you are confident about what it does, then you don't have to write a test or test whether it's working or not, right? Because you already know how it works behind the scenes. So for example, it is typically useless to write tests for getter and setter methods, which simply assign values to fields. Writing tests for these statements is time consuming and actually pointless, as you would be testing the JVM. Now the JVM already has test cases for this. So if you're developing something in Java, it is safe to assume that a field assignment and all of that works properly. So now let's talk about some testing terminology. The code which is tested is typically called the code under test. If you're testing an application, then it is called application under test. A test fixture is a fixed state of a set of objects which are used as a baseline for running tests. Another way to describe this is called as a test precondition. Now, I'm not showing all of this in the video because I'll be putting the links in the description and they have a much comprehensive way of understanding these definitions. But before we actually jump ahead with the practical coding part, we need to understand what these are and talk about them a little, right? So check out the description for the links where you can understand them in depth, the theoretical part, and this video is here to make you understand how we implement everything. So now let's talk about the different terminologies: unit testing, integration testing, performance testing. So now a unit test is a piece of code written by a developer that executes a specific functionality in the code to be tested and asserts a certain behavior or state. The percentage of code which is tested by unit tests is typically called test coverage. Again, the percentage of code which is tested by unit tests is typically called code coverage. A unit test targets a small unit of code, let's say a method or a class. External dependency should be removed from unit tests. So if your particular function is dependent on some external class, or taking something from external libraries or modules, then you can ignore them and only test what that particular function does. Now, how do we do this? We do this with the we do the replacement of external dependencies with a test implementation or a mock object created by the test framework. So JUnit provides, and other libraries provide us with a way to mock those external dependencies. So now, if you want to test the complex user interfaces or how two different software components are interacting with each other, for this you need to develop an integration test which checks the integration of these components. Now, an integration test aims to test the behavior of a component or the integration between a set of components. The term functional test is sometimes used as a synonym for integration test. So you want to test the functionality between two components. Now, integration tests check that the whole system works as intended. Therefore, they are reducing the need for intensive manual tests. So, if I want to test an API or check whether an API is talking to another API, I can run both the APIs in a testing environment and then manually do a post request and check whether something happened or not. Or I could do an integration test that automatically does this for me, saving me time. And it's easy. It's more work for the system and less for the human. Now, the last thing which we talk about is performance tests. So performance tests are used to benchmark software components repeatedly. The purpose is to ensure that the code under test runs fast enough even if it's under high load. Now, in this playlist, we will strictly be focusing on unit tests, which is something a developer needs to write to make sure that the code which they write is working properly before they send it to production. And a unit test is something which I feel is very important for a new software engineer who has just graduated from college, or even for an intern who's working at a big corporation. Unit tests ensure that your code is correct and it is covering all possible test cases. So this particular playlist will be about developing a REST application and writing unit tests for those APIs which we develop. So there are two ways of doing this. One is to first implement a REST API and then write unit tests. The second is the TDD approach, where we first write our test and then we use those tests to build our REST application. And in this playlist, we will be seeing both of those approaches as we go. Now, before we jump on to creating our project, let's just talk about what is behavior versus state testing. Now, a test is a behavior test if it checks if certain methods were called with correct input parameters. A behavior test does not validate the result of a method call. So it only checks if the input parameters were correct or not. State testing is all about validating the result. And behavior testing is about testing the behavior of application under test. Now, if you're testing algorithms or system functionality, in most cases you want to test the state and not the interactions. A typical test setup uses mocks to abstract the interactions so that other classes are not dependent on this. And after that, you test the state or the behavior as you need. So this is some simple theoretical information that we need to know about why we do testing, the reason for why we need to understand what are the different terminologies, etc., etc. Now, for this tutorial, we are going to create a project, a Springboot Maven project, and then we are going to install some dependencies and make sure that our project is up and running for further implementations. So let's go ahead and create a new project. This is what you get when you create a new project. Go to next. Let's give it a name. Let's give it JUnit REST API application, and let's click finish. Now this will give us our application. So Let's wait for a minute for it to be fully loaded. Now the best part about writing tests using IntelliJ and using a main project is that we automatically have a testing folder where we put in all of our tests. So now that we have our repository ready, let's go into SRC, go to main. Here we have Java and resources, but if you see in the SRC we have test as well, and inside test we just have a Java folder. So nothing in it right now, but all of our tests will be inside the Java folder, and it will be inside the test folder, which encapsulates the Java folder. So before we jump into all of that, let's first include all the dependencies that we need for this project, so that we are good to go. So the first thing that we need is our parent. So the parent is going to be having a group ID, which is going to be org.spring framework dot boot, and we have the artifact ID as well, Springboot startup parent, and the version is going to be 2.2. Oh, it's not here. 2.2.2 release. So this will basically have all the typical things that we need for our Springboot REST API and get it started. The next thing that we need are dependencies. So we need a bunch of dependencies, and we'll talk about what all of them are. So dependencies, and now let's add in our dependencies. Before that, let's just add in our build plugin, so that we want Maven to fetch all of our dependencies. So let's quickly add that here. So this basically tells Maven to get our dependencies from the Maven repository and put them inside our local dependencies, Maven dependencies folder. Okay, now what do we need? So first we need some starter repositories. So let's quickly get them inside here. So we need Spring Boot starter web because it is going to be a REST application. The next thing is Spring Boot starter test. It has simple things that we need for our testing environment. Next we need Lombok. So this is basically a very handy dependency which will help us with a lot of annotations and help us with everything which we need for that. And we need a couple of more, so let's quickly add them and then talk about them. So first is Apache Derby. So we since the main intention of this playlist is going to be testing our code, we want to minimize our dependency on external databases. So Apache Derby is an in-memory database which will be up and running just as we give this dependency, and that's all we need to run an in-memory database. Just add this dependency and we are good to go. And the next thing which we need is Spring Boot starter data JPA to have our tables ready, and Mockito is something which I want to save up for the upcoming videos because it is this will require a video of its own. So now that we have all of our dependencies and everything ready, let's quickly have our API runner. So let's go inside SRC, main Java. Let's have a package. So let's say com.rest.application, and inside this we can do REST API runner. And this will be pretty straightforward and boilerplate code. So before we do that, let's quickly refresh our Maven dependencies and add all the dependencies to our project. Should take a minute or so, and I think we're good to go. Now we need to do another Spring Boot application, and we need to have a main method. So public static void main string args, and here we need to run or start our Spring application dot run, and the class which we are running is REST API runner dot class, and we pass in the args we get from the method. Okay, so now we have our simple project ready, and let's run it to make sure that it's running properly. Takes about some seconds to build up all the classes and everything else. Yep, should be up. Hopefully no errors, because we have been doing this for quite a long time. And yep, everything looks good. If you see the data source, you'll see Hikari and everything else, because we're using Apache Derby. So we already have our GPA and everything else, installed, and we literally have a database up and running with our Tomcat server. So yeah, we have everything up and running to start implementing our unit tests, and that is all for this video. In the next video, we will go through some basic JUnit examples, and then quickly move on to building unit tests for our REST API application. So thank you for watching, and I'll see you in the next video.